you stay here and talk loud.
I will.
When you move around, we can't do it.
That's true. Sorry. All right. Welcome to MadJS. This is a JavaScript Meetup group. We mostly talk about JavaScript and generally about web technologies. Welcome. And it's going to be a big group today. That's great. Oops. Yes, there it goes. So we do have a website, madjavascript.com. You can read up on, you can see the latest videos on there, or what the next meetups are going to be, in addition to on meetup.com, of course. We also have our code of conduct, which is an important thing to have in general. So, we record our sessions usually. This is okay to record your session?
Oh, yeah.
Yep, perfect. So Hani graciously spends the time and edits 2 feeds, putting them together in a nice format, puts them up on YouTube. If you go out to YouTube, search for MadJS, you'll see over 2 years now of presentations. So if you missed something, if you couldn't come to a meeting 1 month or whatever, or if you couldn't hear what presenter was talking about, then you can just go back and scan there if you don't want to ask questions in the middle of the meeting. So other than that, there isn't much to say. I'll just go into announcements. I'll throw in a couple of brief announcements. Obviously, we are looking for people to present. So if you're interested in presenting, let one of the admins know. You can let me know, Hani know, or just email us on meetup.com. And of course, we are also looking for people to sponsor for food. Unfortunately, we couldn't find a sponsor this month. Sponsorship brings more people in and gets your name out if you're looking to hire or whatever. Just let us know again. And then the third thing I was just going to mention, so next month we're going to be doing Node School for the Monday. Instead of the presentation format, we'll be doing a Node School format, which is a really good way to learn various JavaScript technologies like Node, or just functional JavaScript was one of the lessons that we went over. Josh went over in Node School. Node School is 100% free. A great way to learn technologies. There'll be people around to ask questions if you're a newbie, or if you're more seasoned and you like giving advice. There'll be people who you're going to give advice to. So those are some announcements from me. If you have any announcements, there's Josh back there. Just go ahead. Yes.
Yeah, so that's a job announcement, but my name's Jared. I work for the WCR, Wisconsin Center for Education Research. We're kind of a sister organization to the Department of Education at the university. We are Microsoft stack, so SQL Server, .NET, C#, JavaScript, lots of Angular. I do a lot of stuff in V3. Looking for another developer. So it's a good job, nice quality of life, tons of vacation, good university benefits. So if you're interested, talk to me after the meetup.
Old job, good job. That's my old job, that's a good job.
Go ahead.
Hi, I'm Josh Thomas. Work at Everything Interactive. Currently we have an opening. Primarily we're looking for front-end developers, and we do React, so if you're interested in working with React, find me afterwards. Thanks.
Well, since we're announcing jobs, I work for Wisconsin Interactive Network. We have a whole bunch of ASP.NET related positions, so Microsoft Stack. We have a couple of senior positions. I think we have a couple of like mid-level positions. So talk to me if you want to.
One more.
Go for it.
Noah, I work for UW Health. We're looking for a Java developer, but we're kind of switching away from Java towards more Node stack. So we're kind of looking for somebody that knows both. We have a lot of Java apps that still support legacy systems.
It's our Java person.
Any other job announcements, cool technologies that you found, or anything? Any other announcement related to web tech? I will also mention Earthling Interactive is paying for the Meetup fees, so just briefly mention that as an endorsement.
Thanks.
So
Thanks a lot.
they help power this. So I think that's it. Let's go ahead and Dustin, you can introduce yourself and go for it.
Right. All right, you are at Taming the JavaScript Dragon with TypeScript. My name is Dustin Ewers. Contact information is on the slide. If you want to look at any of the code that we're walking through today, it's all on GitHub, totally for free, at the link there. So let's get started. So our story begins in the year 1995. 1995 was a year of many wonderful cultural accomplishments. The first of which is Windows 95. We have this great Time magazine cover of Bill Gates looking like he's about to shoot lightning, you know, like he's Emperor Palpatine or something. Poor Steve Jobs. Toy Story, first computer animated movie came out in 1995. I think they required a whole room of servers, all of which are roughly as powerful as my phone. And of course, one of the most important cultural achievements, Gangster's Paradise by Coolio. How many people have enjoyed that? Ah, there we go. Excellent. So, another big thing happened in 1995, and that is the invention of JavaScript, our favorite language here. So, JavaScript was invented by a fellow named Brendan Eich, who, in a Coolio-powered coding frenzy, cobbled together this language in 10 days, which, frankly, is really impressive. I don't think I can do much of anything in 10 days. That's, let alone make an entire programming language that, runs on pretty much everything. But, remember, 10 days, not always enough time to make good choices. So, he built the language for Netscape, and the idea was to put small bits of interactive functionality in web pages. So, it was standardized in 1996, and the rest is history. So, from there, it has taken off to the present day. So, JavaScript now pretty much runs on anything. If it's a computer, if it can run code, you can likely use JavaScript to program it. You got an Arduino? Great. Johnny 5, JavaScript. You want to program a server app? Node.js can take care of that for you. Command line tools, JavaScript has plenty. NPM, Gulp, Broccoli, the one that Gulp replaced. Oh, Grunt. There we go. Grunt. Sorry, Grunt fans. If you want to store some data, you can do that in JSON. JavaScript again. If you want to build a mobile app, there's plenty of good options. You got Cordova, you got Ionic, there's a few others. And, even if you want to build a desktop application, JavaScript is for you. You can use Electron, which powers Atom, Visual Studio Code, and a whole bunch of other code editors. So JavaScript can do anything for you, and it's even on the web. So you can still use JavaScript to build web pages, but not like, JavaScript is no longer relegated to the ghetto of image rollovers and Mad Libs and all the other stuff you saw on that GeoCities website you built back in the late 90s. No. We have all these huge frameworks like AngularJS, and you can build components with React, and you can build your whole website in JavaScript. So instead of just a few hundred lines of code, which is what JavaScript was meant to do, you can throw down, a couple, 10,000K, 100,000K lines of code and build out a huge application using JavaScript. It's great, except for one thing. Alright, sorry. JavaScript, arguably the best thing you can learn, the most versatile tool in your toolbox. It is the Swiss Army knife of programming languages. It can take you anywhere. But there's one problem with JavaScript, one big glaring problem is that it was a hastily thrown together language invented in the mid-90s. And while JavaScript has sort of taken over the universe, and it's gone through many revisions, and is much better than it was in 1995, it still bears the hallmarks of its, of its conception. As you can see, sometimes the good parts, not quite as much as the not so good parts. Let's talk about a few of those frustrations. So, the first thing that kind of sucks about JavaScript is that it uses prototypical inheritance. How many people like prototypical inheritance? Oh, alright, we got a few people. But the thing is, most languages don't really do things that way. JavaScript's got to be different. JavaScript has no inbuilt module support, which is fine if you're writing an image rollover, some small bit of functionality, or even an AJAX request. Not so great if you're writing, 150,000 line application. Typing, how many people are... So there's the age-old debate between static typing versus dynamic typing. How many people are on the side of dynamic typing? Like it better. Okay, we got a few people. Static typing? Yeah, most people, it's fairly... most people don't seem to care too much. But the thing about static typing versus dynamic typing is that dynamic typing is really a good thing if you have a small application. Static typing, you really need it if you're going to write something big. Additionally, JavaScript made some kind of hokey type decisions, like the inbuilt number type is floating point, which is great until you try to build a banking application. And then you run into some issues. And probably my least favorite thing about JavaScript is the scoping. Scoping is ridiculous. Global by default, no block scoping, that this keyword means who the hell knows what based on whatever you happen to be doing with it. Frustrating. So, why do we use it? Why do we use JavaScript? Well, a couple of reasons. As I mentioned above, it runs everywhere. Every web browser uses JavaScript. You can use it to program pretty much anything you want. JavaScript has a lot of smart people in its community. JavaScript really wins because people like Douglas Crawford and John Ressig and all the other people who have built frameworks and written books and come up with design patterns have figured out clever ways to work around JavaScript's failings and really make it a much more usable language. Which sort of brings me to my third point is amazing frameworks. JavaScript, there's pretty much a framework or library for everything you want to do. And most other languages can't really boast that. So there's a lot of great reasons to use it. So how do we get more of what we like out of JavaScript with less of what we don't like? Well, there's two primary ways. The first way is ECMAScript 6, newest version of JavaScript. Recently, is it called ES, or wait, is it ES15 or 2015 now, or is it still ES6? Both, everything. All right, cool. So ECMAScript 6 tries to solve a lot of the problems of JavaScript to make it more usable for large applications. The other thing is just don't write JavaScript at all. How many people have read that Jeff Atwood post on JavaScript is the new assembler? Nobody, but that's okay. I can summarize it quickly. So basically the point is that most people don't write pure JavaScript anymore. They write ES6 or TypeScript or CoffeeScript or some other language, and then they compile it down into JavaScript. And so JavaScript has sort of become the assembler of the web. It runs everywhere, but nobody writes it. So let's first talk about ECMAScript 6, the newest flavor of JavaScript. And it does a few things for us. It gives us modules, which are great, classes that use regular inheritance, not funky prototypical inheritance, and you have better options for scoping variables. Additionally, you get lots of tasty syntactic sugar like arrow functions and string interpolation, which are just nice. So in order to use ES6, you need modern web applications, you need a transpiler, and there's two heavyweights in the space. There's Babel and Traceur. The other option you can go with is you can compile your favorite language into JavaScript. So This includes popular languages like Dart and CoffeeScript and pretty much everything else. So here's a list of over 200 languages that compile into JavaScript. So there's options for C#, Ruby, Python, Erlang, pretty much whatever you want to use. And my personal favorite is COBOL Script. I don't know who has a lot of time on their hands. This person had to be like unemployed or really bored, or they just needed to hate themselves a lot. So let's check out this awfulness. Let's see here. Let's find a relevant program. There's a Hello World program in here that's like 30 lines of code. Oh, that one's not too bad. We'll let it go. But yeah, COBOL Script. Man, why? Wait, here we go. Here we go. This is the one. This is Hello World in COBOL. Why? Why would anybody? Ugh, no. It's comments, but it's required comments, you know. So, COBOL Script, and pretty much any other language you want, but that's okay. So let's move on from that eye-bleeding tear of a programming language. And we're going to get to the hero of our story, which is TypeScript. TypeScript kind of plays in the middle. It's not really a transpiler, but it's not really a new language either. TypeScript is actually a superset of JavaScript, which means that all JavaScript that is valid is also valid TypeScript. So your migration path is as follows. Take .js file, rename to .ts file, you win. That's it. You have valid TypeScript. That's pretty much it. But TypeScript gives you two things. TypeScript is all about giving you tomorrow's JavaScript today. Currently, that's ES6, but TypeScript is beginning to integrate ES7, and I think even some ES8 features on the roadmap are coming into TypeScript. So tomorrow's JavaScript today, and it also introduces optional static typing. So you don't have to type things, but you can, and it's nice. So let's talk about a little history. So TypeScript was invented by our good friends at Microsoft. It was released in 2012 after 2 years, which means that Brendan Eich is way more efficient than Microsoft, but that surprises absolutely no one in this room. It was invented by the same fellow who gave us such hits as Pascal Borland and C#, Mr. Anders Heilsberg. It is open source, a new thing for Microsoft, so it's not proprietary in any way, which is nice. And TypeScript's principal goal is to correct the major failing of JavaScript, in that it makes large JavaScript projects easier to create, manage, and maintain. So what's awesome about TypeScript? Well, static typing, which on its own doesn't really sound that great. Like, you just got to do more work to make sure all of your types jive. But there are some important advantages with static typing that you don't get in a loosely typed language. The first is compile time error checking, which is really much more prevalent in TypeScript than in JavaScript, and that's just really nice for correcting errors before they end up in production. Additionally, it gives you good tooling. So if you like refactoring your code, that becomes a lot easier when you can just rename a method and the compiler can find all the other methods with that name, as opposed to having to, do a find all text replacement and hope that's okay. TypeScript is cool because it gives you access to the latest JavaScript features, and it supports Visual Studio and Visual Studio Code. Who uses either one of those? All right, so a good chunk of folks. The VS Code or the Visual Studio support is great, but if you are not a Visual Studio user, TypeScript is still good for you. So pretty much all the major ones are on the list. So if you like Atom, or if you like Atom, the new school, or if you're really into old school with Vim or Emacs, you can get TypeScript extensions. Sublime, of course, has one. If you have to use Eclipse for work, that'll support TypeScript. Does anybody like Eclipse? All right, you got a couple Eclipse likers. Why?
Because I used it in college.
Okay, that's legit. That's okay.
Because it was better than anything around when it first came.
Yeah.
Splinter, though. You don't know once you remove the splinter and the coin is gone. You're like, oh, I had that splinter down.
Well, to each their own, I suppose. No, I used Eclipse for a while until I became a Microsoft person and left and went to the Visual Studio. So pretty much whatever editor or workflow you have, you can integrate TypeScript into that workflow. So a lot of times I've talked to people about TypeScript at conferences and stuff, and not everybody is a big fan. Not a lot of TypeScript love. So any criticisms of TypeScript anybody wants to bring forth?
Slow.
Slow?
Yeah.
How is it slow?
Compilation slow.
Okay.
That's it.
All right. I haven't heard that one.
So one question about the language: if it's not being transpiled to something, how does it run in all browsers?
It transpiles to JavaScript.
Oh, it does transpile.
Yeah. So it's a transpilation process. You compile it, and it compiles into JavaScript, and it can be either ES5 or even ES3 if you like kicking it old school.
Is it ES6? Is it a superset of ES6 or picks and chooses?
It supports a good chunk of ES6, which is coming very shortly. So that's actually like this slide. So when I first started talking to people at conferences about TypeScript, the major criticism was, why would I use TypeScript when I can just use a transpiler? Transpilers support more ES6 features. And then the other big criticism is static typing is stupid. Well, I don't care about that. So let's look at the one legitimate criticism that I hear. Other than slow, it's fast for me, but I don't know.
Well, there is one other thing. I mean, I've been using it for about 3 months or so. And the only thing that I hit is a speed bump from time to time when you're trying to use a third-party library, and there's these type definition files that provide all static typing for that. Sometimes they're not always up to date with the latest version of library, so there's just a little bit of friction with that.
I think that's legitimate. I think that's a legitimate criticism. Sometimes getting the TSD file set up is a pain. They have and of course they have a tool for that because it's sort of a JavaScript ecosystem thing. But managing yet another package manager can be frustrating. So let's talk about ECMO 6 compatibility. So this is the Kangax TypeScript, or not TypeScript, ES6 compatibility table. Let's make this a little bit more readable. Can we see this? So this chart basically compiles together all of the ES6 features and which transpilers, technologies, etc. support those features, and it gives you a percentage. So up at the top here we see our ES6 transpilers, Tracer and Babel, hanging out at 58 and 71% respectively. But here's the thing. TypeScript also supports a very high number of ES6 features. So despite the fact that it's not necessarily a transpiler, it supports nearly as much as dedicated transpilers do. So the ES6 support is pretty good, and that's actually fairly recent. A couple of months ago, I think it was TypeScript 1.5, they really brought in a lot of ES6 support and kind of kicked up this number, because it used to be closer to like 30%, which, is not that great. So, who uses TypeScript? Apparently, that fellow does. How do you like it other than the TSD issue?
Oh, it's the best thing that's happened in the JavaScript world.
All right. It's the best thing in JavaScript since JavaScript. That's perfect. Microsoft should just steal that, like they do everything else. So who uses it? Of course Microsoft uses it. I worked at Microsoft for about 5 minutes, and we used it to build UI testing scripts. It was really nice for that. The Azure dashboard, if any of you have ever used that, it's this huge JavaScript app. And by JavaScript, I really mean TypeScript. It's over 100,000 lines of code. Angular 2.0 is written in TypeScript. So there is that. And it's used to actually power the IntelliSense for JavaScript in VS Code and Visual Studio. So even if you don't use TypeScript and you also use Visual Studio, it's still helping you out. Because all those hokey TypeScript definition files are what's used to provide the IntelliSense in those editors. So how do you get started with TypeScript? Well, the best place to go is the TypeScript Playground, which is on the TypeScript website, and it's this great little guide, and you can walk through a bunch of different code examples, and you can just run, and they'll come up in TypeScript, and then you can sort of play with them. It's kind of like a JS fiddle for TypeScript, and they take you through the basic features, and then they at the end they give you this big ray tracer thing. But that's where I began, and this is a really just nice place to go. The other good one is the TypeScript Handbook, again on the TypeScript website. It's pretty well written, it's clear, and it just sort of walks you through all the different features of TypeScript. And if that's not good, there's also a TypeScript deep dive book on GitBooks.io, which is, again, free to look at, and it's pretty good too. So you don't really have to pay anything to get started with TypeScript. It's all pretty much free. So let's walk through some TypeScript. So I put together a little one-page guide to the language, and we're just going to walk through all the major features. So TypeScript, it's all about the types. To declare in TypeScript, a type in TypeScript, it's pretty simple. So you just do colon and then the type. And there's a few built-in types like string, bool, number, that correspond to sort of the basic JavaScript types. And then there's also the any type. So for instance, if you're trying to run into like a type, if you're trying to define a library and it's got a funky object and you don't want to define the object for you, you can just define any. And that's sort of just like, it basically acts like normal JavaScript where it doesn't assume what the type is. And it'll also, and so you can see here, you can put whatever you want. And then if you try to put something that's not the appropriate type, it gets mad at you. Tells you that you made a mistake. Which is nice, because it tells you you made a mistake now, as opposed to later. So we can also do implicit typing. So if you assign a string to it, it'll assume it's a string. So if you try to assign something that's not a string, it'll get mad at you.
How is that compatible with JavaScript?
It compiles down into JavaScript.
Yeah, but JavaScript will run that just fine. But you get a compile error.
Well, yeah, you get a compile error because it's telling you you're doing something wrong.
It's
You
not wrong
said
in
earlier that it's a
JavaScript.
superset and that you can change your JavaScript files directly to TypeScript. But if you had something like that, it would, right?
Yeah, get mad at you.
It's not upward compatible with
They can't
JavaScript.
actually run JavaScript.
Yeah, correctly.
Well, you can run correctly written JavaScript.
Correctly. Yeah.
As long, the whole point of TypeScript is to catch these kind of errors before they happen.
Sure.
So if you throw your JavaScript into TypeScript and it throws a compile error, usually you made a mistake. One of the things about TypeScript though is it actually will still compile even with these kinds of errors. It'll actually. Oh, do I need to wait? 10 seconds. All right. All right. So we'll backtrack a little bit. So even if the TypeScript compiler throws an error, if it's something like this, it'll still give you JavaScript. So it's almost like a warning. And I think there's some command line switches that you can fiddle with that'll probably turn some of this stuff down. The idea is that it tells you that you made a mistake. Because even if you were writing JavaScript, that's usually not what you intended to do. TypeScript also supports statically typed arrays. So here's an array of numbers. I throw in an array of not numbers, it gets mad at me, as it should. TypeScript, I really like enums. TypeScript supports those. So instead of like doing string typing, you can actually have a nice enum, which I like. TypeScript also supports generics, so you aren't stuck writing same function for like a dozen types. And those are, you can do the implicit typing with these. So this one will assume it's a string. It'll tell you if you put something in that you're not supposed to, like if I say number and it, gives me that. TypeScript supports classes defined with the class keyword. So here's an animal class. Members are public by default, but it can be declared private if you want. TypeScript also supports static members, which are convenient. You can define a method. And you can have constructors and destructors with your method or with your classes. We have more standard inheritance. So here we have a class that extends the animal class. Here's a static variable. Fun fact, if Scuridae is the species name of squirrel, which nobody here cares about, including me actually. And so we have some methods, some getters and some setters that we can use. And class declarations are pretty much the same as you do in regular JavaScript, where you do the new and you make sure that the first letter is capitalized, for convention. And you can set the variables, etc. And TypeScript also supports interfaces, so we can create an interface. One weird thing that TypeScript does is you can actually create an interface from a class. So here we have an interface, and it's actually extending this class, and so it adds all of the public methods of that class to the interface. One of the things that's not so great about TypeScript is that it doesn't implement those for you. So it doesn't act like in a static class. So if you do this and then you implement the interface, it doesn't actually give you the stuff you took from the class. And it will alert you to your failure. So when you do stuff like that, you want to extend and then implement the interface. And of course, TypeScript also supports modules. So here's a module for string validation. We can export methods and interfaces and classes with the export keyword. So we just have some basic functions, nothing overly special. And of course, this is outside of the module, so it doesn't work. And it will tell you, which is nice. And so that's sort of the one-page guide to TypeScript. So that covers the basic features. Do you have any questions?
So maybe you'll talk about it later, but what kind of functionality does this thing have for that would be comparable to modules?
It has modules.
Well, I mean, like
Do you have module signatures, or are they just namespaces?
They're mostly, here they're namespaces, but they can, I'm not quite sure what you're looking for.
Well,
real module system?
well, like NPM, so, something would tie into Browserify or something like that, something in the packaging type stuff.
Oh, I'm fairly sure it supports that, but I'm not sure if it has exactly what you're looking for. So, sorry for the lousy answer to your question. All right, so let's move on. So this is the sort of the basic.
Sure, it's just something to look into.
Yeah. So let's talk a little bit about tooling with TypeScript. So there's three primary ways. So Visual Studio, of course, supports TypeScript out of the box. If you just name your files to TS, they'll compile in the JavaScript for you. And and the editor is pretty smart about how to reference other things. There's also a TypeScript compiler called TSC. So if you install TypeScript, you get that with the install, and you can use that in whatever build script you have for whatever programming language you happen to be using or editor. And there's also Gulp. There's a variety of ways to use Gulp to compile TypeScript for you. So if you're using more of like a Node.js kind of workflow, there's plenty of options there. There's also a few other tools. So like JSLint, there's also a TSLint that'll lint your TypeScript for you. And there's also the TypeScript definition file. So we kind of touched on this a little bit earlier. But one of the things about TypeScript is it likes to know what the types are. And so there's these TypeScript definition files. And I'll just bring one up here. That is the wrong editor. So let's see here, typing. So this is a TypeScript definition file for jQuery. And basically it just describes what all the different objects in jQuery are, so that when you're using jQuery in your TypeScript, it has a good idea of what kind of types it's expecting. And there's a tool to manage those called TSD. So there's this repository in GitHub called Definitely Typed, and it contains TypeScript definitions for most of the major libraries. Apparently some of them are not perfectly up to date, but it's open source, so you can fix that. And because it's a JavaScript related tool, we have yet another package manager. So if you would prefer to use NPM to manage your TypeScript packages, that is possible. If you're a Microsoft person, most types, a lot of the Definitely Typed stuff is in NuGet, which is how I pulled that jQuery type file in. Not sure if other package managers support the same thing, but this should have you covered. You can also just download them off of the website. If you want, you can just go onto GitHub and download them and manually put them in your project. So whatever works best for you. You can also write them. I'm not going to really dive into that because it's not super interesting. But you can, you just write type definitions for whatever library you have. So if you have a big library that you don't want to turn into TypeScript, for whatever reason, you can just write type definitions for it, and then you can use it in other code. So let's see.
Tooling that you know of that takes TSD files in the JavaScript source and kind of creates a TS for you?
I want to say there is, but I don't know about it off the top of my head. I've heard of it. The problem is, again, JavaScript is loosely typed. One thing you can do that if you want to mock something, you can actually just name it any, and then TypeScript will sort of, treat it like a normal JavaScript object. Another tool to manage TypeScript projects is the tsconfig.json. It contains like the various compiler options and stuff for JavaScript, or for compiling your TypeScript into JavaScript. You can pick like which target you want, or which version of JavaScript you want to target, things like that, which files you want to compile in. Actually, and there's one, so I've kind of gone through the language, and the one-page demo is okay, but I want to show you guys something a little bit bigger. So TypeScript doesn't really shine unless you have something that's less, a less trivial example. This is still pretty trivial. So I built a video game. Built the world's worst video game. How many people have played Kingdom of Loathing? This is like that, except way worse. It's called Ninja's Quest, because who doesn't love ninjas? I love ninjas. It's either ninjas or space ninjas. So we're making ninja. Names? Pick a name. Give me a name.
John.
John the Ninja. Has an epic ninja name. John gets a weapon. We're going to give him a sword. And here we go. So this is real epic gameplay here. So you start off at your home base, and what do you want to do? Well, I'm going to take a nap. Very quietly. Okay, cool. Start off with a nice generic samurai sword. So let's fight a monster. That's the other thing you can do. Bat. We're going to fight this bat. So we can run away. And it's another fun feature that I forgot to take out these breakpoints is that you can actually debug TypeScript files directly in Chrome Tools, which is kind of cool. So here we have our scripts folder. And here's our TypeScript files right next to our JavaScript files. And if you put a breakpoint in here, as I just accidentally demonstrated, that totally works, which is nice. You don't have to go in. And the JavaScript that TypeScript defines actually isn't that awful to read. Like, it doesn't do anything really, it doesn't do anything awful. It's not eye-bleedingly bad. It's just sort of a packaging of, like the module pattern and stuff, and other, best practices, and then some funky stuff to support classes.
So I was going to ask, so that's the generated JS file from compiling your TS?
Yep, this is it right here. So you can still read this, you can still debug it if you want, but Chrome Tools is nice because there's a map file that Visual Studio generates for you, and so you can actually reference the TypeScript directly, which is very convenient. So I like that feature a lot. So let's just get rid of this. So we're gonna fight a monster. We ran away, so we're gonna fight another monster. This one's a large rat, very scary. Let's get him. So the large rat has died a horrible death. You return to base victorious. You get $15, which how a rat is carrying $15, I don't know. The entropy is real, folks. Let's do this again. So there's another rival ninja. Attack him. There's actually a loop here. If you don't hit the guy in one shot, it goes through a non-trivial game. Well, I mean, it's a super trivial game, but there's actually things in this game that are not, it's like a one-page guide. So let's look at how let's look at how to put this together. So if we go here and you go to the game, we have a variety of scripts. So the first script, we'll start with characters. So I have a module. That module is game. All of my game-related things are here. So we have a character class. We have some basic statistics about your character. Here it's a weapon. Apparently I'm missing a reference, but TypeScript it's okay. It's somewhat forgiving. We got some methods, and we're extending. That's kind of scary. The TV like melt on us or something? Oh well. We'll continue. So we have a hero class, our ninja. He extends character, gets a few other extra pieces of data that go with him. And then there's the monster class, also extends character. And then there's a few extra things that go with the monster. We give him a special constructor to determine his attack. So we also have an encounters, and this is let's try that. Hopefully Hani edits all this stuff out. Talk is going to be like half as long after all this stuff is edited out. Alright. This actually doesn't throw this compiler in Visual Studio. Visual Studio is smart enough to know that my stuff is in other files. I think if I threw like a JS or a TS config in here, or put in the reference comments, it would actually reference appropriately. So this is my fault. But again, this still all works, so that's good. So we have a game module. We just have we have a few extra classes that go with it, and some weapons. We define a few weapons with the weapons interface. And as you can see, we use the various features of TypeScript give you a relatively clean object model that just there's not a lot of fluff. We don't have to do a lot of things to work around the JavaScript language. It's just standard OOP looking code. And here we have just some basic stuff here. We have different weapons that we can implement. This is what the rats get, the claws. And then all of that comes down to this this game.ts. So this is sort of the central place here. And I define a variety of functions that sort of compose the game. So beginning the game, making a character, etc. And these use the module, or use the game module that we created. Yeah, this is awesome because VS Code doesn't pick up any of this type stuff, whereas Visual Studio is much smarter about it. So sorry about that. So yeah, so we have all these different functions that use the game module that we created. And then we just hook these up with some pretty standard looking jQuery to the various buttons on the page. So here we have an example of just using TypeScript to build a somewhat complex application. And you can see how this would expand for a real application that you would create that doesn't, unfortunately, involve ninjas. Any questions about this?
So in my mind, I'm trying to compare the module system of TypeScript versus that of ES6. Now, I would expect to see like import statements at the top of some of your TS files, which I don't see.
There's references and stuff. I'm not. We can actually look at it if we want. Let's see here. We'll just look at. Yay, links. I think there's different ways for the modules to work in TypeScript. So let's see here. There's a couple of different ways to reference files. Here we have these sort of reference comments that we can put in our TypeScript. So if you want to pull in specific things, we can also use the TS config files to define a range of folders. Visual Studio is pretty smart about just picking stuff out for you, so you don't really have to work very hard in Visual Studio. And I also use bundling to put all of this stuff into one file, so you don't really have to import anything, because it's all just kind of there.
Module in TypeScript is more like a namespace really than a node module. Sure.
Yeah, but they also here we go. We also have import statements. So here's the import statement here. So we can do imports. I remembered we could. It was just a matter of trying to find the appropriate documentation and actually remembering how to do it. So we do have more of a Node.js kind of thing.
That's for Common.js. There's a normal looking import statement. Normally, not with the require statement.
Okay, now with the require statements.
So I don't know why they're not showing on this page.
Well, here's the require one.
So you can use ES6 imports style.
So there we go. We all learned something, including me. So we have a variety of ways to use modules, so it's not just the sort of namespaces only. Thank you, people who actually get to use TypeScript day to day. All right, so let's see here. So that pretty much. Thank you, Impress.js. All right, here we go. So major takeaways. JavaScript everywhere. We use it in all sorts of places. Microcontrollers to the cloud, but not really great for building large applications. And TypeScript is there to address that primary weakness with a variety of features. So, any questions?
Do you have to use, in a practical way, Visual Studio? And you did mention that there are compilers, but how practical it is for a person who doesn't own Visual Studio, for example, to just use those transpilers and those compilers and start?
Well, there's a couple of different options. I think Sublime has a pretty good TypeScript plugin, as does Atom. There's actually a free TypeScript IDE that you can get that exists. I haven't really used it at all, but it's sort of a web-based editor, kind of along those lines.
So the compile
Seems to work right well and compiles in line when you save it, compiles it.
Yeah, and you can also set up your JavaScript workflow. You can put like a gulp watch on there, and you can actually compile it on save as well using gulp.
I guess my question is the compiler reliable enough to produce JavaScript that runs everywhere?
I haven't had any issues with it. So, anybody else, more experienced TypeScript folks, run into any problems? Yep, WebStorm was on that editor list. I didn't mention it, oddly enough. I don't know. There's actually I actually have a demo of TypeScript in a Node.js app. Unfortunately, I didn't have enough time to write one of these, so I just stole one, and it doesn't work. It used to work, but apparently something broke, and I didn't have enough time, so I apologize to you for that. But here's the gulp file, and it actually uses the gulp TSB package, and you sort of compile, either like this, or you can compile on the fly using like a gulp watch. So you have options. And you can also get Visual Studio Code, which is free, and it's a lot like Atom, and you don't have to pay anything for it. You actually don't have to pay anything for Visual Studio, just regular Visual Studio anymore, because they have that Community Edition. But if you don't want to use Visual Studio, there's lots of available options, so you aren't stuck using it. Any additional questions?
So among your editors that you've worked with, by any chance, do any of them do refactoring? The old I've got this method, I want to rename it, that kind of thing?
Here, let's try it. So let's go to, here's one. Here's a really poorly named method, so let's just name this something else. So let's call it, yeah, I had to go back to Visual Studio. I'm sure that it would work okay in VS Code if I actually had all of my references in VS Code correct, which I clearly do not, because I wasn't, because I was expecting to use Visual Studio. So yeah, I mean you get basic refactoring. In this you just use Control-RR. You don't need anything special. It's built into Visual Studio. There's similar refactoring tools in VS Code. I just don't know the shortcuts because I don't use VS Code for major development tasks. It's just more of a fun thing, or if I need to edit like a lot of lines of code at once.
We had a presentation on VS Code a few months ago. Maybe,
Scott Addy, right? Yep. I think I've seen that. I think I've seen it at conferences before. I talk to Scott fairly often. So yeah, there's good refactoring support. You can also do things like find all references. Just kind of convenient. You can sort of click around. Not something you can easily do in JavaScript, but TypeScript it's fine. Any other questions?
More of a comment, really, but from what I've found for Visual Studio, for those in the room who use it, Visual Studio 2015 has really great support for TypeScript. Visual Studio 2013 is moderate, and 2012 is sort of fairly functional. I think it can support 1.0 of TypeScript, which in my opinion is way better than nothing. So like my team right now, we're still on 2012, and definitely we're still using TypeScript. But yeah, it's only going to support 1.0, but that gets better and better with VS 2013 and VS 2015. So
I think VS 2015 support's pretty good.
Yeah,
Well, and they just came out with the new version of TypeScript. So previously I had to use the comment reference files that we saw in the documentation to make sure everything worked together. But once I updated TypeScript, I didn't need those anymore, so I actually got rid of them, which is probably why it's not working in VS Code. But what can you do, right?
yeah, on that note, do you need a certain type of project in order to get that good support?
It's mostly an editor feature. So if your editor supports TypeScript, I think each of the different extensions has different features that use it. Now, obviously, Visual Studio is going to be really good because Microsoft made TypeScript to work really well in Visual Studio. But again, there's other things. I have not tried them all. I have built TypeScript apps in Visual Studio primarily, and then a little bit in VS Code, but not a lot. So I don't know how much refactoring support you get in like WebStorm or other things. I mean, it's obviously possible, but I just don't know if it's there.
Are there any options to run in fully statically typed code?
I mean, fully is there like are you expecting something that's a little bit more?
Can you turn off dynamic typing?
I don't know. I mean, if you put the type annotations, it'll get mad at you, but I don't know if there's a way that it just blows up. There's a lot of compiler switches, and I have not memorized any of them.
That was it like disabling implicit any, so if you don't have the type defined, just default any, if you turn that on, it won't let you do it.
Okay. So it's kind of there. TypeScript is, even though it'll like throw compiler errors and squigglies at you, it's relatively forgiving. I think the idea is they don't want you to drop your JS in and then just be completely unusable. But there's, again, configuration that you can do.
Right, they sort of made TypeScript so that large classes could adopt it. Like, if there was no dynamic typing at all, you couldn't apply it to existing projects, it would only be new projects. With the way they built it, it's all like.
And you've got finer grained control of the typing too, so you can say, well, this parameter, it's either a number or a string. Because a lot of times you do that with JavaScript, so it's got all that flexibility.
Well, you can also just, declares any if you don't want, if it's something that you don't necessarily want to define. Any other questions? Oh, wait.
Does typing include classes?
Yes, typing does in fact include classes and interfaces as well. So in the game example, there's a couple of instances of declaring something as something else. So it's like right here. So we're declaring a weapon as an I weapon, so as an interface. And then in the game up at the top, you have our hero is a hero and our monster is a monster.
And it also has all the typings for like other browser stuff that you would expect, like an HTML element and all of that fun stuff too. So
Yeah. Though in Visual Studio you get a lot of that in the standard like JavaScript IntelliSense, but it's again it's a little bit more strict in TypeScript.
Does it support classical inheritance or just like JavaScript prototyping?
Well, this is classical inheritance, but if you look at the actual code that it compiles, it modifies the prototype. So it's, again, it compiles down to JavaScript, so you have to deal with the prototypical inheritance, but it is it's classic to you, even if it's not classical to the JavaScript. Good?
I was just curious, was that blank, was that photoshopped, I presume?
Photoshopped by somebody who was not me.
Was not an engineer.
Yeah, not an engineer. I actually tried to include more 90s references, but apparently I really wanted Surge, which was invented in the late 90s, and those Razor scooters, also late 90s, so I couldn't, I could only go so far as Coolio with the Brendan Eich joke, so what can you do? All right, well, that's it.
Thanks, Dustin.
Yeah, no problem. I will.
So, a reminder, next week, or next month, Node School. You haven't determined what the two classes will be, but if you have.
I haven't figured out what we're going to cover yet, but we do have an open thread on GitHub for